Hi everyone, and welcome to this video where we are answering 20 questions on bounds and errors. You can find the link to these questions in the description if you want to print them out, have a go at them yourself. Otherwise, you can also find them all on the crackmaths.co.uk website, as long with plenty of other material to help support you in your GCSE Maths. Okay, so let's have a start at this first question here. And this first question says, a length is recorded as 12 centimetres rounded to the nearest whole number. Write the error interval for the actual length. Okay, so 12 centimetres rounded to the nearest whole number means that if we've got our 12 here, it was either going to be rounded to 11 or it was going to be rounded to 13, because they are the whole numbers either side of 12. And then if we want to do this here, we look now for the midpoints. So the halfway point between 11 and 12 is 11.5. The halfway point between 12 and 13 is 12.5. So basically, everything between 11.5 and 12.5 would round to 12. So therefore, that is our error interval. So if I want to write this down here, we've got 11.5 here. I'm going to put length in the middle, and then I'm going to put 12.5 up here. Now remember, everything that is 11.5 or above will round to 12. Everything that is strictly less than 12.5 will round to 12. So therefore we use these symbols here for strictly less than and greater than or equal to. So with that, we now have our error interval, which tells us that length is greater than or equal to 11.5 and less than 12.5. Okay, right, let's have a look at question 2. So question 2 here says that a temperature is recorded as 8.4 degrees Celsius rounded to 1 decimal place. Write the error interval, so 1 decimal place this time. So if we've got 8.4 in the middle, 8.3 would be the 1 decimal place before that, and 8.5 would be the 1 decimal place after that. So let's sort this out here. We've got 8.35, and here we've got 8.45. So there we go. So we've got temp is greater than or equal to 8.35, and we've got that it's less than 8.45. Okay, right, let's have a look at the next one. Question 3 says, distance is recorded as 3.46 kilometres rounded to 2 decimal place. Find the upper bound for the distance. Okay, so 3.46, the next thing it would be, if it were rounding to 2 decimal places, would be 3.47. So then we find the midpoint from these, which will be 3.465. Okay, and then that midpoint is the upper bound, because that is the point, all the numbers up to that point round to 3.46. Okay, so that is the boundary lines. That is the upper bound for that. We all know that 3.46 would round up, but the upper bound for we all know that 3.465 would round up to 3.47. But we know that the upper bound for this bit would be with 3.465. Okay, so there we go. Upper bound equals 3.465 km. Right, question 4. A weight is recorded as 150 grams rounded to 2 significant figures. Write the lower bound for the weight. So what we've got here is, if it was 150 to 2 significant figures, the one below that would be 140. Okay, so the midpoint between these two is 145. So the lower bound for the weight equals 145 grams. Okay, right, question 5. A height is recorded as 700 metres rounded to 1 significant figure. Find the error interval. Okay, so the height is recorded as 700 metres correct to 1 significant figure. So that means we rounded to the nearest 100, because one significant figure means the first value. Okay, so it was going to be 700. If it wasn't 700, it was going to be 600. If it was larger than 700, it was going to be 800. So then what we do is we find our midpoints. So halfway between 600 and 700 is 650. Halfway between 700 and 800 is 750. Okay, and then that gives us our error interval. So we've got 650, we've got height, we've got 750. Okay, and the height is greater than or equal to 650 because 650 would round up, and it's strictly less than 750 because 750 would also round up. So we don't want to include that in the error interval. Okay, right. Question 6. A rectangle has a recorded length of 10 centimetres rounded to the nearest centimetre and a recorded width of 6 centimetres, also to the nearest centimetre. Calculate the upper bound for the area. Okay, so for the area, because we're just timesing the length by the width, it's timesing. So the way that we get the biggest result is by having the biggest number. Okay, so let's do what we can with this. So the upper bound for 10 to the nearest centimetre, well, the next thing to the nearest centimetre would have been 11. So the midpoint for that is 10.5. So the upper bound for 10 is 10.5 because 10.5 would round up, but everything up to 10 would round down. And then the upper bound for 6, well, 6, the next number would be 7. Okay, so then that would be 6.5. So the upper bound for 6 will be 6.5. So the area of a rectangle is length times width. Okay, so let's work out what that will be. So that's going to be 10.5 times 6.5. And this seems like a job for the calculator. So let's get the calculator out and bring it over here. Here we go. Here we go. And we can do 10.5 times 6.5. And there we go. The answer will be 68.25 centimetres squared. 68.25. Okay, and I'll just move the calculator out of the way so you can see what I wrote. Right, question 7. A rectangle's dimensions are 4.5 by 3.2, both rounded to one decimal place. Find the maximum possible area. Okay, so we've got 4.5 and 3.2, so we need the upper bounds for those. So for the upper bound for 4.5, it will be 4.55. The upper bound for 3.2 will be 3.25. And we're going to multiply these together. So I'm going to get the calculator out. So here we go. 4.55 multiplied by 3.25. And there we go. We've got this lovely long number here. 14.7875, and it's an area again, so it'll be meters squared. Okay, right, let's have a look at the next question. Here we go. Question 8 says a rectangle is 8 meters long and 5 meters wide, both to two decimal places. Find the lower bound for the area. Okay, right, so okay, this is a bit trickier. Let's do the error intervals for this. So the lower bound, so it's to two decimal places, okay? So it was 8.00, but two decimal places. So if we think about two decimal places, that's this number here that's changing. So if we had gone higher, that'd be 8.01, but we went lower, so it's going to be 7.99. So the lower bound for this one here is going to be the midpoint between 7.99 and 8.00, which is going to equal 7.995. Okay, so that's the lower bound. And we've got this bit here. The lower bound for the other one, we've got 5. Okay, so again, if we had 5.00, the upper bound would be 5.01, and the lower bound is 4.99. So the midpoint between 4.99 and 5, which would be 4.995. So now we've got our two lower bands, okay? So these are the lowest values that we could have had that would have rounded to 8 and 5 to one decimal place. So let's multiply these together to get the area, okay? So we're just doing 7.995 times 4.995, and let's find out what that equals on the calculator. I believe it's going to be something long. Okay, here we go. Sorry, I just need a drink. Right, okay, so here we go. It's going to be 39.935025 meters squared. There we go. Right, let's have a look at question 9. So question 9 says a rectangle is 25 centimeters by 12 centimeters. Both values rounded to two significant figures. Find the minimum possible area. Okay, so minimum, so 25, so it would have gone to 24 if it rounded down. So the lower bound for that is 2.45. It's not 2.45. It's 24.5. So that's the lowest value that would round to 25 to one decimal place. The lower bound for 12 is going to be 11.5 because that's the lowest value that would round to 12 for one decimal place. So then we just need to multiply these things together and find out what that is. Again, let's use the calculator. So we have got 11.5 times 24.5. And here we go. That is going to be 281.75 centimeters squared. There we go. Right, question 10, and that finishes for the practice ones, and then we'll have a look at the 10 scenario questions. Okay, so here we go. Question 10 says a rectangle is 13.5 centimeters by 6.8 centimeters, both rounded to one decimal place. Work out the lower bound for the area. Okay, so right, it's one decimal place. They want the lower bound. Okay, so we're going to be looking at 13.45 times 6.75. Okay, because both of those are the lowest things that would round to 13.5 and 6.8 to one decimal place. Let's get out the calculator and solve these here. So 13.45 times 6.75. Okay, done. Right, and that's centimeters squared. Right, let's move on to the practice questions. The scenario questions, you've just done the practice questions. Right, here we go. So question 1, let me just move this out of the way, says a road sign shows the distance to a town of 18 kilometres rounded to the nearest kilometre. What is the error interval of possible actual distances? Okay, so if it's 18 kilometres, it would have gone to 17 or 19 had it rounded up or down, which means that we're looking at 17.5 and 18.5. So there we go. We've got distance is less than 18.5 because remember 18.5 would actually round up, and it's greater than or equal to 17.5. Okay, next one, we've got question 2. It says here, a bottle is labelled as containing 1.5 litres of juice, rounded to one decimal place. What is the upper and lower bound for the actual volume? So if it's 1.5 to one decimal place, it would have gone to 1.4 or 1.6 in a different life. Then we find the midpoints, 1.45 and 1.55. So everything between these two values is what rounds to 1.5. So we've got here the volume is greater than or equal to 1.45 and it's strictly less than 1.55 because as we know, 1.55 would round up. Okay, right, here we go, question 3. Question 3 says, a car's speed is recorded as 70 miles per hour, rounded to the nearest 10 miles per hour. Write the error interval for the actual speed. Okay, so it's rounded to the nearest 10, so it was either going to be 60, 70 or 80 in the different worlds. Okay, midpoints here are 65 and 75, so everything within those midpoints is what rounds to 70. So here we go, we're going to have the speed in the middle, greater than or equal to 65, less than 75. Okay, right, let's try question 4. So question 4 says, a plank of wood is 2.00 meters long, rounded to 2 decimal places, find the error interval. Okay, so we've got 2.00 here. It's been rounded to 2 decimal places, so the next one up would have been 2.01, and the next one down would have been 1.99. The midpoints of these are 1.995 and 2.005. So here we go. These are the bounds of our error interval. So what we get is we've got length, and then it's greater than or equal to the lower bound, and it's strictly less than the upper bound. So there we go. Right, question 5. We've got here, a house is listed as £250,000, rounded to 2 significant figures. What is the upper and lower bound of the actual values? Okay, so it would have either been 240,000 in a different world, it was 250,000, or if it had been rounded up, it would have been 260,000. Okay, the halfway marks between these are, we've got our 245 and we've got our 255. Okay, so there we go. If we've got all that, we know now our price. It was greater than or equal to 245. I'll put the pound sign there. And it was less than 255 even. 255. There we go. Right, perfect. Right, last 5 questions in the scenario one. Let's see how all this all goes. So what we've got here is we've got question 6. A rectangular window is measured to be 1.2 meters wide by 1.5 meters tall, both to 1 decimal place. Calculate the maximum potential glass area. Okay, right, so maximum potential glass area is going to be the maximum area of the rectangle, so we need the upper bound for both of these measurements. So they've been rounded to 1 decimal place, so the upper bound for 1.2 is 1.25, and the upper bound for 1.5 is 1.55, and I can times these together and see what that gets. And this is a calculator activity, so 1.25 multiplied by 1.55. Here we go, and that equals 1.9375 meters squared. Right, question 7. We've got here a rectangular rug is labelled as 2 meters by 3 meters, each to the nearest 0.5 meters. Okay, this is a bit different actually. What is the lower bound of the floor area it might cover? So to the nearest 0.5 meters. Okay, so if it was 2 meters, okay, if we're going up in 0.5s, the 0.5 below that would be 1.5. The 0.5 above that would be 2.5, okay? The midpoints of these, remember we can get these by adding the values together and dividing it by 2. So if I do 1.5 add 2, that gets me 3.5. Half of 3.5 is 1.75. And then that's the lower bound, so I don't actually need to bother with the upper bound for that one. In fact, let me just remove that information there. So that's the lower bound for that bit. Now we've got 3 here. Again, it was to the nearest 5. Well, the nearest 0.5. So the 0.5 below that would be 2.5. And then the midpoint of these two is going to be 2.75. Okay, so the lower bound of the area is going to be these two things multiplied together. So let's whip out the calculator for that. So here we go. We've got 1.75 multiplied by 2.75. Okay, here we go. So that is 4.8125 meters squared as our lower bound. Nice. Okay, question 8. It says here that a rectangular phone screen is said to be 14.2 centimeters by 6.9 centimeters, with both measurements rounded to 1 decimal place. Find the upper bound for the visible area of the screen. Okay, so 14.2, the upper bound for that, if it's 1 decimal place, would be 14.25. 6.9, the upper bound for that would be 6.95. Okay, because these are the maximum values that would round down to these numbers to 1 decimal place. So then we just need to multiply these together to find the area of the screen. Okay, so here we go. We've got 14.25 multiplied by 6.95. Here we go. And that equals 99.0375 centimeters squared. Okay, right. So, question 9. A rectangle has a length, we've got a different word here, has a length of 5.2 meters and a width of 3.7 meters, both rounded to 1 decimal place. Find the upper bound for the perimeter. Okay, so the perimeter is the distance around the shape. So in this case, it's going to be the length, add the length, add the width, add the width. Okay, so let's find the upper bounds for these numbers. They've both been rounded to 1 decimal place. So the upper bound for 5.2 will be 5.25, because that's the maximum value that rounds down to 5.2. And then 3.7 would be 3.75. And then, so what we've got to do is we've just got to do 5.25, add 5.25, add 3.75, add 3.75. Oh, 1 second. 3.75. I've got the point in the wrong place. 3.75. So this is 10.5. Add 7.5. And that equals 18. Ah, there you go. That's a nice answer for a change. 18 meters. Okay, right. Let's have a look at question 10. And then we are done. So well done if you've done all of these questions, and I hope they've been making sense to you. So here we go. Question 10 says, a square tile has a side length of 12 centimeters measured to the nearest centimeter. Work out the upper bound for the area of the tile. Okay, this is nice. Just one thing to do. Okay, right. So the upper bound, if it's 12 centimeters to the nearest centimeter, the upper bound for that would be 12.5, because 12.5 would technically round up to 13, but it's the benchmark for what rounds down to 12. Okay, so if it's a square is the side length times the side length, so that's 12.5 times 12.5. Here we go, and let's get the calculator out for that. 12.5 times 12.5. And here we go, that is 156.25. Excellent. Okay, great. Well, thank you for joining me for that, and hopefully see you in another set of questions. So long.